Hi, my name is Deepika. I'm a PhD student at KTH in Sweden. This presentation is about RIC, our test generation tool that observes applications as they execute in production with the goal of generating unit tests with mocks, stubs, and mock-based oracles. Consider this method called getTurnDescription defined in a class called via_instruction within an application called GraphHopper implemented in Java. GetTurnDescription takes in a parameter of type translation. It does some computations and it returns a string. Let's call this method an MUT or a method under test. We also notice that within this MUT, there is a call to TR on an object of type translation, which is an external object. When writing a test for getTurnDescription, a developer might want to mock the translation object because it's an external object and also stub the behavior of the method TR called on this mock object. This is precisely what we mean by mocking. Mocking is the act of, or the technique of replacing an actual object with a skeletal implementation, which brings more focus on testing the method or component under test, and it has many benefits. However, it's also challenging because developers would first have to identify what can be mocked and also how the mocks should be stubbed. So that is how their behavior is to be defined within the test. And for this reason, there have been several techniques proposed in the literature to automatically generate mocks. For example, mocks can be generated through search-based methods and also symbolic executions, and mocks can also be derived from systemic test executions. However, while these techniques are very useful, the mocks that they generate are not guaranteed to reflect actual production behavior. So the question then arises, can we generate mocks from actual production usage? That is, mocks that reflect how an application actually behaves when triggered by users in production scenarios. And the answer is yes, we can. We do this with the tool that we implement called RIC. RIC operates in three phases. In the first phase, it identifies MUTs and mockable method calls within the application. Then, while the application is executing in production, RIC monitors the invocations of MUTs and mockable method calls, and corresponding to these invocations, RIC collects some data. And then in the last phase, RIC generates unit tests with this data, and these unit tests have mocks, stubs, and mock-based oracles. Mock-based oracles are of three types. The first type is the output oracle, which verifies that the output of the MUT within the test is the same as it was in production. Then we have the parameter oracle, which verifies that mock method calls are invoked with the same parameters as they did in production. And then we have the call oracle, which verifies that mock method calls occur in the same sequence and with the same frequency within the test as they did in production. So quick recap. RIC first identifies MUTs and mockable method calls within the application. Then, as the application executes in production, RIC collects data corresponding to the invocations of MUTs and mockable method calls. And finally, it uses this data to generate unit tests with mocks, stubs, and mock-based oracles. Let's now look more closely at GraphHopper. GraphHopper, like we discussed, is an application implemented in Java. It tells us the route between different locations on a map. So for example, we can ask GraphHopper for the route between 3 locations in Sweden. But while we do that, we can use RIC to collect some data corresponding to the invocations of MUTs and mockable methods within GraphHopper, and then use this data to generate mocks. So here we have a screen recording of GraphHopper being used with RIC. We invoke the server of GraphHopper as we normally do, but we add RIC as a Java agent. And when the server is ready, we head over to the UI of GraphHopper and ask for the same route between the same 3 locations. But while this happens, RIC collects data corresponding to the invocations of methods, which it then uses to generate tests. So here, again, recalling the example of the MUT and the mockable method call that we discussed before, RIC generates 3 tests for it, 1 test for each kind of oracle. The test that we see here has an output oracle, and it has the arrange, act, assert. It follows the arrange, act, assert pattern. Within the arrange phase, we see that we deserialize the receiving object from its production snapshot. The receiving object is the object on which the MUT was invoked. Then we mock the translation object, and then we stub the behavior of the method tr called on this translation object. Next, we invoke the MUT, that is the getTurnDescription method, with the mock translation object. And finally, in the assert phase, the output oracle verifies the output that we should expect to get from this invocation of the MUT. Next, we have the test for the parameter oracle, which verifies that the method tr should be called with this parameter, which is the one that we observed for this invocation in production. And then we have the call oracle, which verifies that tr should be called exactly once within this invocation of the MUT getTurn description. For more on RIC, we invite you to scan this QR code and read our paper, and also try the tool out for yourself. Thank you so much for your attention.